Thank you everybody for joining us today. Um, Yesterday we covered the residential updates to the 2018 and from the 2018 to the 2021 IECC. Today we're going to be covering the commercial portions. In the interest of time, we've got a lot to cover. Normally we have some poll questions and stuff to keep things rolling along. We're probably going to skip over most of those today just to keep moving through the content of the presentation and fit it within our lunch hour here. Joining me today is Robert Schlorf, an architect in our office. My name is Sean Maurer. I'm one of our mechanical engineers. If you have questions for us during the presentation, please drop those into the Q&A chat window. If you put them into the standard chat window, we might miss them or have to dig them out. We'll get to those at the end of the presentation. We're going to try to just zip through this and fit it within the hour, and then we'll address your questions at the end of the presentation. So to start things off, again, my name is Sean Maurer. Joining me is Robert Schlorf. Who we are here at CDAC, we're an applied research program with the mission to reduce the energy footprint of Illinois and beyond. How do we do that? We help facilities become more energy efficient through some of our assessment programs. We conduct education, we do research, and we advocate for a greener future for the state and beyond. We want to thank our program sponsor, the Illinois EPA Office of Energy. They help keep this program going, so we thank them for their support. We are an ICC preferred education provider, and we do offer continuing education credits for AIA. As you registered, you would have submitted with your registration your membership numbers that we can submit that information for you. If you are attending this call with someone else, make sure to follow up with an email after the fact, and we'll be sure to get those continuing education credits for you. The webinar is recorded, so if you have hear something you didn't catch or something, you can always go back, find it on our website, and look at that information afterwards, and we'll upload the slides so you can have access to them as well on our website. If you have questions, either in practice day-to-day or after this webinar, you can follow up with us at our email, energycode@illinois.edu. We also have a 1-800 number if you have a quick call question that we can answer. That number is available. We do prefer email as a method to answer questions. It gives you the chance to have a written response that you can share with the code official, builder, whoever needs to have that information. But for quick questions, that 1-800 number is also available. As I mentioned, our workshops and webinars are recorded and uploaded to our website, smartenergy.illinois.edu/energy-code. We also have self-paced on-demand training modules that you can take there. We have the 2021 IEC modules have been up since last program year. So if there's something you wanted more detail on in our presentation, you can start with those modules and see if it's contained in there. If not, please do follow up with questions at our helpline. Yesterday's presentation were by popular demand, but starting in April, we'll go back to our regularly scheduled programming. We'll be talking about simplified code compliance, how to look at the code, and use the content of the code to simplify your designs and how to comply with the code. Then we'll touch on existing commercial buildings in May, and in June, we'll have a Q&A review where we go details about how we answer your code questions to help you develop those skills for yourself. So as I mentioned, today's presentation, we're talking about the commercial updates to the 2021 IECC. The November 7th meeting, JCAR approved the 2021 IECC as the baseline code for the state of Illinois and the proposed amendments, and made them effective on January 1st. So if you're applying for a permit on January 1st or after, then the 2021 IECC is what you must design to. If it was before that date, then the 2018 IECC. But that's based on the permit date, not the start date of the design. So pay attention to the permit date for which code is the one that you have to apply. For access to the codes, we have links on our website. We also have the direct links here in the presentation, which will be available to you at the end on our website. The Chicago Energy Transformation Code also has its own version available on the ICC website. And the state is looking to have one that has all the Illinois amendments blended into it, published as well. Once that becomes available, we will share that with everybody. Today's learning objectives: identifying key changes between the 2018 IECC and the 2021 IECC, identifying how compliance with the Energy Conservation Code would lead to safer buildings, improving compliance with the code for commercial buildings and how that will reduce pollution, and describing the Illinois amendments to the 2021 IECC for commercial buildings and their impact on compliance. I will now turn it over to Robert to get into our first section on the envelope and some updates to definitions.
All right, thank you, Sean. All right, so let's start with a few quick commercial definition changes here. So in the 2021 code, they have some new or updated definitions regarding IT equipment, data closets, and data centers. So these are broken out as equipment buildings, where there is equipment power that is equal to or greater or equal to 7 watts per square feet. And we'll talk a little bit more about those in a few slides. Computer rooms are defined as rooms that have equipment with less than or equal to 20 watts per square feet or less than or equal to 10 kilowatts of ITE load total. And ITE at the bottom of the slide there is information technology equipment. And then data centers will be the step above computer rooms. So those are spaces that are greater than 20 watts per square feet or greater than 10 kilowatts of ITE load total. So the key here is to identify what type of equipment is within the space and what the load of that equipment is, and then that can help you determine the designation for that space, whether it be a computer room or a data center. Moving on, there have been some updates to the climate zone maps within the 2021 code. So within Illinois, there are 6 counties that have been moved from 5A into 4A. Those 6 counties are Calhoun, Clark, Coles, Cumberland, Greene, and Jersey. So again, these 6 counties have been moved into the warmer climate zone of 4A. So keep that in mind if you do work within these areas. And that's it for the quick definition slides there. So we're going to go ahead and jump into the commercial envelope updates. Before we get into the changes in the commercial envelope, we're going to just go over this list of buildings that are exempted from the Illinois Energy Code. These are buildings that are exempt from locally adopted building codes. So essentially, if a building permit is not required for the project, the Energy Code does not apply. A building code or a building permit is what triggers application of the Energy Code. So if it doesn't apply building permit, Energy Code isn't necessary. Buildings that don't contain any conditioned space, buildings without comfort conditioning, listed historic buildings, or other buildings as specified within the IECC. These categories are unchanged from the last code cycle. We just wanted to go over them really quickly. All of this information is denoted within the Illinois Admin Code if you want to look up more details. Quick note about historic buildings there is that a report needs to be given to the building officials or building department stating specific reasoning why complying with the code would harm or in some way lead to a detriment of the historic nature of that building. There's a little bit more about historic buildings within the IECC itself as well. All right, so next, this is a new requirement for commercial buildings within the 2021 IECC. If you're familiar with the residential requirements, this will look familiar to you. The commercial provisions are now requiring a commercial thermal envelope certificate to be permanently installed within the building upon completion of construction. Typically, this is going to be located within a mechanical room, potentially electrical room near the main electrical panel, something like that, in a location that's easy to see. Is not going to get covered up by other information. And what needs to be recorded on this certificate is the R values of insulation within the different assemblies for the building. So the roofs, walls, foundations, slabs, crawl space walls, floors, and even ducts. You're also going to record the U factors and solar heat gain coefficients for your fenestration around the building, as well as results from building envelope air leakage testing, which we'll talk about a little bit later, but that is also a new requirement in the 2021 code that buildings do need to be tested for air leakage. So that also needs to be recorded on this certificate. If you happen to like the look of this certificate that we have here on the screen, there's a version of it that is free for anyone to use. That's available on our website following that link there on the screen. We also, at the same location, we also have the residential certificate if you would like to use that one as well. Moving on. Okay, greenhouses. So greenhouses is a new section that's been included under the low energy buildings section within the 2021 code. Greenhouses are being called out as similar low energy spaces, but have their own specific requirements. And so these requirements are that the opaque envelope assemblies of that greenhouse. So if there's a rat wall below the fenestration or any other opaque portions of that greenhouse must comply with C4022, the exterior wall insulation tables, as well as C40245, so air sealing. So we want to make sure that the opaque envelope assemblies are fully insulated and air sealed as they would be for any other building. Point 2 here, internal partitions between the greenhouse and any other conditioned space must also comply with C4022, C40243, which is the fenestration U factor and solar heat gain coefficient, and then C40245, again, air sealing. So point 2 is essentially telling us that we want to make sure if this greenhouse is connected to any other structure that is conditioned, that the connection between the greenhouse and that structure creates thermal isolation for the greenhouse so that we don't have unintended heat transfer between the conditioned space and this greenhouse. So we want to make sure that there are fully code compliant external assemblies between the greenhouse and the other conditioned space to create that thermal isolation. And then point 3 here, so the fenestration for the greenhouse must be in compliance with table C402111, which is the recreated there below. And so the skylight requirement would be for the non-vertical portions of the greenhouse, and then the vertical fenestration would follow for the vertical fenestration requirement there. And there is an exception for unconditioned greenhouses. They do not need to meet these requirements. So these are for conditioned greenhouses. All right, so we would get back to equipment buildings. There has not been a significant change in this provision since the last code cycle. So the only thing I'm really going to cover here is that the square footage has been increased from 500 square feet up to 1,200 square feet. So equipment buildings can now be up to 1,200 square feet. Otherwise, the requirements and designations for equipment buildings have remained the same from the 2018 to the 2021 code. All right, moving into the insulation tables for exterior assemblies or for thermal envelope assemblies. So on the screen here, we've recreated a portion of C40213. The highlighted cells represent cells that have had their requirements increased or changed since the last code cycle. The 2018 IECC values are shown there in the white text with brackets. So as we can see, the roof insulation value for attics has been increased. It is now R49 in all climate zones and groups. Metal buildings have also had their continuous insulation requirements increased, along with metal framed walls. Again, the continuous insulation requirement has been increased there. Wood framed walls, there's a fairly big change there in that there is no longer a cavity only option. The two options for wood framed walls in the 2021 IECC are R13 cavity insulation plus R7.5 continuous insulation, or R20 cavity insulation plus R3.8 continuous insulation. So you may have heard us talk about this before, but the code is really pushing for the use of continuous insulation, getting at least some of the insulation on the outboard of all of the framing. It really helps to limit and prevent effects of thermal bridging, and that continuous insulation on the outside of the framing can also give us a really nice, easy plane for air sealing on the outside of the building rather than on the interior of the building. So the code's really pushing for that continuous insulation there. And then there have been some changes within the below grade wall requirements for Group R buildings as well. Continuing on here, so pulling out the floors. Again, the green highlights, the green cells highlight where changes have been made. White text shows the original 2018 values. So we see that the mass floor requirements and unheated slab requirements have been changed. One note here about heated slabs is that the insulation is permitted to stop at the bottom of the slab. The way that we interpret this footnote is to say that any heated slab should be wrapped, both perimeter, sides, and bottom, in insulation as a way of isolating it from the surrounding structure. This would be considered best practice. If that heated slab isn't fully wrapped, there can be thermal breaks between it and foundation walls or other elements that help some of the heat or some of the energy that you're trying to heat that floor with escape from the floor. That's not exactly where we want it to be. We want it to be heating the floor and not going anywhere else. So the interpretation of that note there is that heated slabs should be fully wrapped. If insulation is broken by a stem wall on a heated slab, say the foundation requires that the stem wall breaks that insulation level or that breaks that insulation at the perimeter of the slab, then the perimeter insulation should extend down the full depth as stated within the code, so 24 inches below. Um, there's also been a clarification and refinement of different door types within the 2021 code. These requirements have been expanded due to new door types, so taking consideration of different types of horizontally hinged doors or garage type doors, overhead type doors, and then those doors have become a lot more common in bars, restaurants, and other public spaces, and so the code is capturing those doors and making sure that they're defined separately from other door types. And then the requirements, insulation requirements for doors, have been moved from the R value table to the U factor table. We aren't going to show you the U factor table today, in hopes of moving this along as quickly as we can. So to reference the U factor tables, do see the 2021 IECC. All right, tapered roof assembly. This section has been modified from the 2018 code. Previously, the 2018 code used phrases like "such as" at roof drains to talk about when the roof insulation can taper down to the deck. The 2021 code language places more restrictions on minimum thickness, exceptions for specific cases, and there's also a specific separate section for U factor compliance that mirrors these R value requirements here. The major update and simplification here is that the average U factor or R value is allowed for compliance, where previously the IECC placed limits on added thickness that would count towards the R value. So again, you're allowed to use the average R value for tapered deck insulation. And then to go through the bullets here quickly, the minimum thickness shall be 1 inch if we're using 2 staggered. Otherwise, we want a minimum of 2 staggered layers throughout the rest of the roof, except at gutter, edge, drain, or scupper locations. And then, as I said, C4021411 sets comparable requirements for U factor compliance. This is a fairly quick slide here. The 2021 code has made it clear that any spaces that are designed to, in accordance with ICC 500 as storm shelters do not need to meet the minimum skylight requirements stated in the code. In previous code cycles, this likely would have still been the case. It just would have been an exception due to safety concerns or for safety reasons, but now the code has gone ahead and clearly stated that these storm shelter spaces do not need to have the minimum skylight requirements. All right, there's also been a change and there's been minor changes in the U factor requirements for fenestration, but the biggest change here is actually how the 2021 code organizes this section. Orientation is no longer how solar heat gain coefficient is determined. Now solar heat gain coefficient requirements are determined based on whether the window is operable or not. There is a note here that this could remove some potential trade-off capability as the fenestration for fenestration, as the solar heat gain coefficients are likely to be more uniform around the building than they might have been before based on orientation. The code's making this change to recognize that there are performance differences between fixed and operable fenestration, and that difference between fixed and operable is potentially more significant than the difference between orientations. So just keep in mind there that that's no longer determined by orientation, but by fixed or operable. Next, we have a Illinois amendment that was added in. This Illinois amendment essentially aims to ensure that buildings with large amounts of east or west facing glazing compensate for the high heat gains in those area orientations. So the solar gain on the east and west facades of a building is often quite a bit higher than the south side of the building. So this amendment recognizes that fact and essentially imposes a penalty for buildings that have significant east and west exposure. The overall result of these requirements is that if the area of the east and west fenestration exceeds 25% of the total building fenestration area, then the east-west fenestration must have a 20% better performing solar heat gain coefficient than the base code minimum value. So again, this is aimed at trying to counteract high heat gains from east and west glazing. And this impacts rectangular buildings as well as square buildings. So just keep this in mind when you are designing from scratch, that significant amounts of east and west glazing do need to be addressed via this amendment. All right, minimum skylight area. So the same required toplit areas as 2018 code, the 2021 IECC has retained those same toplit areas. The major change within this section in the 2021 IECC is that the language and the language and requirements have been updated to recognize tubular solar systems or tubular daylighting systems, as shown in the image there. So these systems work quite a bit differently than traditional box type skylights, and so the code is now recognizing that since these are becoming more prominent and used in different locations, that the code's going to specifically call them out and make sure that the requirements match how those solar tubes work, since they work slightly differently than box skylights in terms of bringing light into the space. Otherwise, there have been fairly minor updates through this provision or section. Next, probably the biggest impact of a new provision here is the changes to air barrier compliance. So buildings or spaces including Group R and Group I occupancies shall meet C40252, which is the dwelling and sleeping unit enclosure testing. All other buildings shall meet the C40253 building thermal envelope testing requirements. There are no exceptions listed in the code for climate zones 4A and 5A. So what this means is that all new commercial buildings within Illinois must now be pressure tested. And we'll go through the next couple slides here. We'll go through the requirements for each of those sections listed above. But again, due to the updates in the 2021 code, all new commercial buildings within Illinois need to be pressure tested. So what does that mean for dwelling and sleeping units? Well, so dwelling and sleeping units, and again, these are dwelling and sleeping units that are located within commercial buildings. So we're talking about larger multifamily buildings, potentially hotels, those sorts of buildings, but dwelling and sleeping units within commercial buildings. The measured air leakage shall not exceed 0.30 CFM per square feet of testing unit enclosure area at 0.2 inch of water gauge or 50 pascals. For multiple units within a single thermal envelope, the code designates that you should test each individual unit and use envelope area weighted averages. If you have a building with multiple units, units should be tested separately with unguarded blower door tests. If there's more than 8 units, if there's less than 8 units, you test all of the units. If there are more than 8 units, you test at least 20% of them, which is a minimum of 7. This sampling of units must include a top floor unit, a ground floor unit, and a unit with the largest enclosure area. So whatever the largest unit happens to be within the building. And then each unit not in compliance requires 2 additional units to be tested. So that just means that you want to pay attention as much as you can there to ensure that the testing doesn't take longer than it needs to. So pay attention to air sealing details within the units to make sure that you don't have to keep testing further units. And then I note here that the code does specify a guarded test for dwelling and sleeping units. A guarded test, if I'm remembering correctly, yes, a guarded test requires that the space, the unit, be pressurized or depressurized while the units around it are not pressurized or depressurized. So we're only testing one unit at a time. We're not trying to pressurize or depressurize the whole building at once, just each individual unit. Part of the reason for this is that it also helps it helps prevent any sort of transfer between units. So any sort of indoor odors or cooking smells, smoke, that sort of thing from transferring from unit to unit. This testing method also helps us verify that firewalls are constructed appropriately, and that there's no air transfer between units. All right, moving on to all other types of commercial buildings. So the target and the test pressure are slightly different here. So keep this in mind that this is for non-dwelling and sleeping units, but for all other commercial buildings, the measured leakage shall be less than or equal to 0.4 CFM per square feet of thermal envelope area at 0.3 inch of water gauge or 75 pascals for the whole building test. So again, slightly different requirement and testing pressure there. There is an alternative sampling approach for a large building. So we're talking about high rises here, or potentially other large buildings that have unusual volumes where it would be difficult to test the whole building. In that case, you can test sample portions of the building on an area weighted average basis that can't exceed the whole building leakage limit. So in this case, you're going to be required to test samples that are the entire envelope area of spaces directly under a roof, spaces that have an entrance, spaces that have an exposed floor, a loading dock, or spaces that are below grade. So all of those spaces need to be tested, and then 25% or more of a representative sample of the remainder of the building after you account for all of those spaces listed in the first bullet point there. This last bullet here at the bottom is a really important one. There is a performance buffer built into this requirement. If the total leakage is between 0.4 CFM per square foot and 0.6 CFM per square foot, the code allows for diagnostic testing and non-destructive remediation to be performed without requiring another test, without requiring another building pressure test. So if this is basically saying that, well, you're close, but you're not exactly there yet, but you're within this little buffer zone. So we won't make you test again, but you do need to go around the building with some diagnostic testing, potentially smoke pencils, thermal imaging, something like that. Perform any non-destructive remediation that you can, and then the code will say that you have complied with this requirement. So again, there's a little bit of a performance buffer there. All right, another new requirement within the 2021 code. This is one of many requirements that helps to bring the IECC into a little bit better alignment with the most recent version of ASHRAE 90.1. This requirement also, again, recognizes the prevalence and popularity of overhead doors in public spaces. So this requirement is operable openings interlock, basically for any conditioned space that has a door opening that is larger than 40 square feet to the outdoors shall be provided with controls that change the HVAC settings when this door is open. These controls must be configured such that they disable the heating or lower the heating set point to 55 degrees or lower. They disable the cooling or raise the cooling set point to 90 degrees or higher, and both of those must be done within 10 minutes of the door opening. So again, this code is recognizing that these types of overhead doors have become fairly popular in lots of commercial spaces. Those spaces are really nice and they have good connections with the outdoors, but what we want to make sure is that our HVAC systems are not trying to condition the outdoors. We want to make sure that that conditioned air that we paid for to keep everyone inside the building comfortable is staying within the building and not just flowing out the door. So that's what this provision is aiming at, is making sure that we don't waste energy with these large doors. All right, moving into the additional efficiency requirements. So formally in the 2018 IECC, projects had to choose and implement one additional efficiency measure. Now in the 2021 IECC, projects must collect 10 points, which is equal to about 2.5% additional energy savings. Point values are listed in tables based on occupancy group. And we've highlighted a couple here just to point out that yes, 10 points seems like maybe a high number of points, but there are a couple credits where you can get all 10 of those points, or a couple of these efficiency options where you can get all 10 points with just implementing one measure. One of those is C4068, which is the enhanced envelope that offers 1 to 10 points depending on the climate zone and occupancy group. And then the second one there, C4069, reduced infiltration, again offers up to 11 points depending on the climate zone and occupancy group. So that, don't let that 10 points scare you. It may not be as hard to achieve as it sounds like at first. And just to show what a representation of a recreation of one of the tables looks like here. So again, these additional efficiency measures are listed along the left side. Climate zones are listed along the top row there. And then we have different occupancy types listed and the points for each measure. So as you can see, enhanced envelope performance and reduced air infiltration provide quite a bit of points depending on what climate zone you're in, especially climate zone 5A. One more quick addition to the additional efficiency measures here is that the Illinois amendments, the adopted Illinois amendments, did add 2 additional options to this list. So these are C40613, demand responsive HVAC controls. So essentially HVAC controls that have some connection to the grid and are able to respond and react to signals from the overall energy grid in terms of managing their load. And then similarly, C40614, demand responsive water heating controls. So both of these, the C40613 offers about 2 to 4 credits, depending on the climate zone and occupancy group. And then C40614 offers 0 to 2 credits. Refer to the Illinois amendments for a little bit more details and information about those. At this point, I'm going to go ahead and pass it back off to Sean to talk about commercial HVAC.
All right, thanks, Robert. We do have a number of questions coming in. Just a reminder, we'll get to those at the end. So I know we're zipping through. We're not ignoring you. We will answer your questions. So updates to the mechanical section. C40331 has specific requirements for equipment sizing for data centers and HVAC systems now added, where this was not a separate section in the 2018 IECC. So equipment sizing must comply using the modified ASHRAE 90.4, sections 6 and 8. And the modifications are contained in the 2021 code. We won't get into them in detail, but know that there's a slightly different load calculation methodology for data centers than there is for other building types. And we really want to stress doing proper equipment sizing, because the typical standard is that equipment gets oversized, either based on rule of thumb estimates or conservative estimates. And that can result in equipment that doesn't cool properly, doesn't dehumidify properly, and doesn't achieve its efficiency ratings. So proper sizing is very, very important for HVAC systems. The 2021 has expanded the equipment efficiency table significantly. It's added in specific efficiency tables for VRF systems, indoor pool dehumidifiers, dedicated outside air systems, and heat pump and heat recovery chillers. And then it's added some clarification on some other tables by expanding or separating out content that was previously contained in the 2018. So computer room air conditioners and condensing units have been separated out into their own table and have different requirements for floor mounted versus ceiling mounted systems. And water source heat pumps have been broken out separately from other heat pump type systems into their own table as well. So that's expanded the number of tables. In the 2018, it was 10 tables. There are now 16 different reference tables for unit efficiencies. Efficiency is increasing. So something that many of you may have seen in industry already is that the SEER, HSPF, and COP ratings are being updated to SEER 2, HSPF 2, and COP 2. If you have a unit that has a SEER rating, there are ways to convert that to SEER 2, and the result should be a slightly higher value for the equivalent older rating. What these changes are accounting for are slightly different estimates of loading throughout the season, trying to account for part load efficiency of these systems. And then gas-fired warm air furnaces have also had their efficiencies increased in these tables. So even though the SEER ratings are updating to SEER 2, HSPF to HSPF 2, they're also increasing the efficiency requirement of those systems in those tables. Supplemental heat controls for buildings that are installing heat pump technologies. There is specific language regarding supplemental electric resistance heating for those units. Previously, the code had a pretty vague definition of when supplemental heat could kick on. It was just when the compressor couldn't supply the heat load. As it's now bullet pointed out, 4 bullet points that specifically state conditions when emergency heat can be applied using the control system. So when the compressor cannot provide adequate heating, so there's some sense that the system is running in heating mode, but it's not keeping up because the temperature is not increasing or has decreased at the thermostat, then you can kick on that supplemental heating. If the heat pump is in defrost mode, obviously the compressor is not supplying heat then, so the supplemental heat can kick in that instance. If the vapor compression system malfunctions, or the thermostat itself malfunctions and isn't adequately triggering that compression cycle of the heat pump. Heat pump isolation. So if you have a water source heat pump system with loops larger than 10 kilowatts and those now require 2-position automatic valves interlocked with the compressor. So with heat pump systems tied into a hydronic loop, this is just isolating geothermal heat pumps or water source heat pumps that are not actively providing heating or cooling to that hydronic loop because of staging, so that you're not wasting that heat through the heat exchanger of that heat pump system. Only the active system is going to have active connection to that hydronic loop. The 2018 IECC had automatic start language in it. The 2021 has now added automatic stop as well. And so automatic stop just allows for the building to start coasting a little bit slightly before the scheduled unoccupied time of the building, so that spaces will drift only about 2 degrees before the scheduled unoccupancy period begins. This is just a way to conserve energy, particularly as peak energy draws tend to happen around that same time that buildings are starting to go unoccupied, around 5, 6 o'clock in the evening. So it's a demand control measure built into the code now. Economizers, not a whole lot of change here, but a clarification update. In the 2018 IECC, the only exceptions for economizer installation were based on reduced operating hours for economizing or limited economizer benefit due to heat recovery or humidity control requirements. This resulted in a lot of questions from people about VRF plus DOAS systems. Did those require an economizer, even though they have energy recovery, and there's not a whole lot of benefit to an economizer on those systems? So the 2021 has specific language acknowledging that those VRF technologies are much more efficient and that an economizer has limited benefit. And so they are included in the exceptions for economizers. We do want to note that this is based on a VRF system with a 3-pipe heat recovery option installed, where you can move heat within the building. If you don't install that option, you do a VRF system that cannot exchange heat between individual spaces in the building or zones in the building, then an economizer might be more beneficial. But again, you're looking at the trade-off there, and the code doesn't require it for those types of systems. It excludes all VRF systems from having to have an economizer installed with them. Demand control ventilations had a slight update in the occupant density that triggers when DCV must be applied. In the 2018, it was 25 people per 1,000 square foot. It is now 15 people per 1,000 square foot or more. So more spaces will now be required to have that demand control ventilation installed. The exceptions for DCV also got some minor modifications for clarity. So there's a couple of additional bullet points, but the essential requirements are the same for the exceptions for DCV. They did also reduce the design outdoor airflow exception from 12,000 CFM to less than 750 CFM. So again, making it a little bit more stringent, making demand controlled ventilation applicable to slightly more spaces. For enclosed parking garages, again, some minor updates. 2018 had an exception allowing for a garage with total exhaust capacity of 22,500 CFM or less that did not use mechanical heating, to not then have to ventilation controls for those parking garage spaces. The 2021 updates that CFM limit to 8,000 CFM. So again, making it a little bit more stringent, making this apply to slightly more space types, garage areas. Dwelling versus non-dwelling unit requirements for energy recovery. Non-transient dwelling units have enthalpy recovery of 50% of cooling design and 60% of heating design. The cooling enthalpy recovery ratio is exempted for climate zones 4 and 5, so only the heating side enthalpy ratio is considered, and then the cooling side is whatever you can achieve when the heating side meets that 60% target. For all other spaces, the tables and exceptions are unchanged as far as the minimum airflow that triggers when you have to have energy recovery. Another significant update as far as fan efficiency for buildings, the fan efficiency index is now being used instead of the fan energy index. What was noted in the past was that for varying different performance levels, you would have the same fan energy index, um, fan efficiency index. The fan energy index better accounts for the entire system, including VFD, banks of fans, and how they perform. It accounts for changes in shaft power, VFD, and stuff in that value. So we're now using that fan energy index instead of the old efficiency index. Low capacity ventilation fan efficacy. So this is looking at primarily in residential style spaces in commercial buildings where you've got kitchen exhaust vents or restroom fans, things like that, that are smaller in size. This table has been slightly updated to align with the residential ventilation fan efficacy requirements. So it's a pretty significant overhaul from the 2018 IECC requirements for small horsepower fans. Electrically commutated motors with 70% efficiency, must have adjustable speed, was the only requirement in the 2018 IECC. So now you've got this table of requirements where you have to meet the fan efficacy as well. There's also some exceptions that were in the 2018 IECC that have been removed in this section. So airflow is required to be tested and verified as well. So as we covered yesterday in the residential, you have to test these exhaust fans to make sure they're achieving their labeled CFM airflow rates. Same thing on the commercial side. If we're going to install these systems, you got to make sure that they're achieving the ventilation rate that they're designed for. As Robert noted earlier, there are additional efficiency requirements updates. You have to collect the 10 points now. We've highlighted here the ones that apply to HVAC systems. Robert covered a couple of Illinois amendments earlier that also touch on HVAC systems and those point values. We can't touch on all of these in the time allotted to us here as far as their point values, but you can find those in the 2021 IECC. And again, most of these aren't going to get you 10 points in one go. You're probably going to do a couple of HVAC measures to get to that 10-point value, but they do have a range depending on the type of building and the climate zone. Grid integrated controls, as Robert mentioned earlier, this is an Illinois amendment for HVAC systems and domestic hot water systems to have grid integrated controls. So we've put the requirements on screen here. But all thermostatic controls should be provided with a grid integrated control capable of these things, automatically increasing the zone temperature cooling set point by 1 to 4 degrees, decreasing the zone heating set point by 1 to 4 degrees, ramp up and ramp down logic to prevent peak demand from exceeding that expected without demand response, as an alternative to the thermostat specific set point changes. Similar things for domestic hot water. If you're in the 40 to 120 gallon range with an input rating of 12 watts or less, then you're going to have the demand response controls, and you get some limited credits for having demand response in place. But again, we're looking to avoid peak demands, help even out load on the grid so we don't have extreme peaks that are detrimental to grid stability. So these are the points available for those different systems. Recovered and renewable water heat, notice in about the middle of the screen there, offers some significant points for residential and institutional because of the heavy domestic hot water demands in those buildings. Um, and same thing for efficient water heating. But in general, most of these you're going to be picking a couple of these points or pairing them with other higher point values in order to get that 10-point limit. And I'll turn it back over to Robert to go through our commercial lighting.
All right, thank you, Sean. I'll try to go through this fairly quickly here to leave us some time to answer all of your questions. So firstly, a new requirement for dwelling units within commercial buildings again. So this is going to differ from the residential building provisions. Just keep that in mind that this is dwelling units within commercial buildings. Not less than 90% of the permanently installed fixtures shall contain only high efficacy lamps. High efficacy lamps are defined within the code as not less than 65 lumens per watt. So again, just making sure that 90%, not less than 90% of the permanently installed fixtures have high efficacy lamps. This excludes kitchen appliance lighting. Quick update to the requirements or the spaces that require occupant sensing controls for lighting. So the rest of this list is unchanged. The bold number 10 down there, corridors, have been added to the list of spaces that now require occupant sensing for lighting. We'll talk about the requirements of that here in a couple slides. There have also been some modifications to the occupant sensor control function in warehouses section. So in this, the modifications now say that lighting within warehouses must reduce lighting power by at least 50% when unoccupied within 20 minutes. The controls must cover aisleways and open areas. Control for each aisleway shall be independent and shall not control beyond the aisleway. Additionally to this, there must also be a manual control provided to turn off the lights. And any lights that are not turned off by an occupant sensor must be turned off by a time switch control complying with C405221. So you're either going to have occupant sensors controlling the lighting or you're going to have time clocks controlling the lighting. Moving on to occupant sensor control within open plan offices. Now, these are open plan office areas that are greater than 300 square feet, greater or equal to 300 square feet. The total lighting zones must be limited to 600 square feet total. The controls must reduce lighting power by at least 80% in a reasonable uniform pattern within 20 minutes after no occupancy. The controls must turn off general lights in all zones within 20 minutes of occupant leaving, or you can reduce lighting to an unoccupied set point of 20% or less within 20 minutes of occupant leaving. So if your design, or if for some reason you decide that turning all the lights off is unsafe or unadvisable for some reason, you do have the option to reduce lighting power to a minimum set point of 20% to make sure that there's some safe passage lighting within those spaces. And then lastly, daylight responsive controls may activate fixtures only if occupants are present. All right, so occupant sensor control within corridors. So this is a new section, as I said earlier. Controls within corridors, occupant sensing controls must reduce lighting power by at least 50% in a reasonably uniform pattern within 20 minutes after no occupancy. There is an exception listed for corridors with less than 2-foot candles of lighting on the floor at the darkest point with all lighting on. So this is, the code is saying that if we have a particularly dark corridor for some reason, we don't want to make that corridor any more unsafe than it potentially already is, and so we will make sure that these occupant sensing requirements are exempted in that case. So the code is keeping an eye out for occupant safety. Light reduction controls, there have not been significant updates to this section within this code cycle. But this is essentially lighting reduction controls for all other spaces that we didn't previously cover and that are not covered by other specific sections. The intermediate step here listed under that first point there, so manual control to uniformly reduce lighting by at least 50%, but must include an intermediate step between 70 and 30% power. or use continuous dimming control again with a minimum set point of 20%. So that intermediate step there is the new requirement here. And that also, as I mentioned earlier, is another instance where the IECC is becoming more aligned with ASHRAE 90.1. There are exceptions listed below here that generally apply to spaces or configurations that don't really allow for uniform dimming, or if the control isn't cost effective within that space. Daylight controls. So daylight controls are largely the same as 2018 IECC, except that the 2021 code now incorporates primary and secondary daylight zones, which again is another alignment with ASHRAE 90.1. Um, uh, the exception to requiring daylighting by reducing allowable lighting power per the equation below may be more enticing with this addition of secondary daylight zone control requirements. So keep that in mind, that you may have you may be able to take advantage of that exception with the addition of these secondary daylight zones. Exterior lighting controls. There have been minor changes throughout this section. The primary change is that what used to be called decorative lighting is now called facade and landscape lighting. So other than that, the requirements are mostly the same. There are some general exceptions for all exterior lighting. These general exceptions are lighting for covered vehicle entrances and exits from buildings and parking structures where it's required for eye adaptation, and then lighting controlled from within dwelling units. Those two items are exempt from the general requirements under C40527. There are updates to the interior power allowances. The grand majority of those updates being a reduction of about 10% for the largest reductions. A few spaces saw lighting power densities increase. So just keep that in mind. We're not going to cover most of those today, but just to keep that in mind, there have been some minimal changes within lighting power allowances. Speaking of parking garages, parking garage lighting controls have been given their own specific section within the 2021 code. Parking garage lighting must have daylight responsive controls within 20 feet of the perimeter wall openings to reduce lighting power by at least 50%. There are some exceptions there that may apply depending on what the design of the exterior walls are. If there's architectural screening or anything that has an effect on the levels of light, there may be some exceptions there. Occupant sensing must reduce lighting power throughout the parking garage by at least 30% within 20 minutes of inactivity. This excludes zones provided with less than 1.5 foot candles on the floor at the darkest point. Again, tying back to that, what I said about corridors earlier, the code is keeping safety of occupants in mind here, making sure that those particularly dark spaces aren't made darker by occupant sensing controls. And then, as I said, the last slide there, eye adaptation zones for the entrances and exits of parking garages must be controlled separately and must reduce their power by at least 50% from sunset to sunrise. So those have specific controls there for the eye adaptation zones at entrances and exits. Lighting for plant growth. This is an Illinois amendment to the code. All permanently installed luminaries for plant growth shall have photon efficiency of not less than 1.7 micromoles per joule per ANSI and ASABE S640 for greenhouses, and 2.2 micromoles per joule for all other indoor growing spaces. So it would define depending on what the space is, if it's a greenhouse or just another indoor growing space. There is an exception listed for buildings with no more than 40 kilowatts of aggregate horticultural lighting load, and facilities subject to Illinois legislation for in-state cannabis facilities. Automatic receptacle control. This is another new and potentially big change in the 2021 code, that automatically controlled receptacles are now required within certain circumstances here. So the automatic receptacle controls are required in at least 50% of receptacles in all enclosed offices, conference rooms, rooms used primarily for print and or copy functions, break rooms, classrooms, and individual workstations. They are also required in at least 25% of branch circuit feeders installed for modular furniture that is not shown on the construction documents. So, and just to kind of cover automatic receptacles, these are receptacles that are set up and controlled to where if someone forgets to turn something off, the receptacle itself will turn off whatever device is plugged into it. So some of the items that might be good for these things are cup warmers, office space heaters, small fans, other small appliances, potentially other electronic devices if it's not going to be if it's not going to interrupt any processes by being turned off. But essentially, these automatic receptacles are going to turn off the things that occupants typically forget to turn off. These small appliances can add up to some fairly significant plug loads for a building, and so the code is trying to address those plug loads by including some requirements for automatic receptacles. You can control these automatic receptacles by time of day basis, occupant basis, so potentially occupant sensors or some sort of security badge system at the entrance to the building, or on a control signal basis. These receptacles must be permanently marked as controlled, as you can see there in the image. Also, one quick note from us here is that a strict reading of C40511 actually requires that the top receptacle be the controlled receptacle. How this will be interpreted in the field, we're not exactly sure, but you may have to ask your installers to pay careful attention to what the top receptacle is, depending on if the building standard is ground up or ground down and what units are purchased. So just keep that in mind, that there could potentially be a strict location of the top outlet being controlled there. Moving on, one more slide before questions here. So energy monitoring, C40512. This is another new requirement in the 2021 code. Measurement devices shall be installed in new buildings to monitor the electrical energy for the following systems: HVAC systems, interior lighting systems, exterior lighting, receptacle circuits, large process loads, and building operations and maintenance. This new requirement only applies to buildings that are 25,000 square feet or larger. And this is another alignment between the IECC and ASHRAE 90.1. Won't go into this too much, but monitoring the electrical loads throughout the building can really help to identify if there are any problems within any of these systems. We can see if the energy use is abnormal or unusual, and then we can know that that system needs to be looked at or needs to be repaired in some way. So this helps us to understand how our building is operating to make sure that there's not unintended energy usage happening in any of these listed systems. So that takes us to the end of our lighting and systems section here. So I think we can go ahead and start answering some questions.
All right, I think we'll do a couple of the quick ones that came in back with insulation. The first one was, is R5 insulation under the entire building slab for heated slabs, or is it some number of feet from the perimeter? And for a heated slab, it's under the entire area of the heated slab. So if you have a portion of the slab that isn't heated, the R5 would go under the heated portion, and then you'd have to have that thermal break between the heated slab and the unheated portions of the slab. And then there was one about the energy certificate. Can we expand on that certificate? When is it issued? When is it verified? So that certificate goes in right before building occupancy. So after your as-builts have been reviewed and approved by the plan examiner, the building itself has completed all its inspections, then that certificate goes into that space. It can also be included in the building owner's documentation, as long as that certificate is somewhere that it's not going to be lost, covered up. The purpose is similar to what it was for residential buildings. You want future owners of that property to know what types of windows are installed, what type of insulation is installed, so that if they have to do repairs or replacements, they can match the performance of what was there or improve upon it.
There's a question about the Chicago code. I was going to drop a link in there from our website. Chicago has their own energy code for the city of Chicago, the Chicago Energy Transformation Code. So I'm not sure if that question is intended for the city of Chicago itself or just the Chicago area, but the Chicago Energy Transformation Code, the 2022 version, became effective November 1st of 2022. That version is not exactly the same as the state's energy code. There are some differences between the two, but to answer that question, I'll drop a link into the answer here, taking you to our website with some more information about the Chicago Energy Transformation Code. And then I see a quick question here at the bottom of our chat that says, keep hearing new construction. Yes, today we are just covering new construction. We don't have the time to talk about the existing building requirements today as well. We do have some information on our website, some modules that cover existing building requirements within the 2021 code. And we will likely have some webinars in the future that cover existing buildings. We did have one earlier this year that covered existing residential buildings under the 2021 code, but we are not covering existing commercial buildings today.
We do have a webinar coming up in May that will cover
Yes, thank you.
existing buildings.
Yes.
Yeah. By and large, though, those requirements have not changed between the 2018 and 2021. So if new construction requirements would have applied to an existing building in the 2018, those requirements would still apply in the 2021. There's some minor changes and clarifications that happened for change of use of occupancy, where that's been now moved into the building additions portion of the code for certain types of change of use of occupancy. But that's the only change that happened for existing buildings. Question here about pressure testing for institutional occupancy. Can the non-sleeping compartments have a separate test requirement? So yes, the sleeping and dwelling units have a specific sleeping and dwelling unit test that has to be done. The rest of the building would have to meet the sampling testing of the commercial building sampling procedure.
And there was a similar question in the chat that asked if there are stipulations for warehouse envelope testing. There aren't necessarily specific stipulations for warehouse envelope testing. Those would fall under the non-sleep dwelling and sleeping unit testing requirements. So potentially you could follow the sampling approach with a large warehouse, although you will have to test everything that is under the roof. And although warehouses are a fairly large volume, that's not really that much different from other large commercial buildings in terms of testing them. So there are no specific stipulations that I'm aware of for warehouses in particular.
There are provisions in the testing procedures as well. If you, for some reason, cannot achieve the test pressure of 75 pascals for the warehouse structure, there's ways to prorate that leakage that you measure to get to an estimate of what it would have been had you met that 75 pascals. So there are ways to calculate that if you don't achieve that test pressure during the testing. For another question came in the Q&A here about commercial buildings needing blower door testing. Are there exceptions that apply to climate zones 4 or 5? No. There are exceptions in there. Exception 3 applies to certain areas. I would have to pull up the code book, which I don't have right in front of me to identify that one specifically. But for climate zone 4 and 5, there are no exceptions that apply to the climate zone for pressure testing of buildings. So all commercial buildings in climate zones 4 and 5 must be pressure tested.
So the heated slab question there. So a heated slab is a slab that has heating elements within it. So a radiant slab, or potentially something that has hot water radiant piping throughout it, or sometimes potentially some sort of ducting system within the slab, but it is a slab that is directly heated through some means. That's what we're talking about when we're talking about a heated slab. And yes, that insulation under it is under the entirety of the heated slab.
Question here about insulation for slab installation at dock levelers. This is going to be a tricky situation as you've got a moving piece of equipment that ideally, since it penetrates into the interior of the thermal envelope, should be insulated and isolated against the outdoors. But because those levelers can move, the panel on the outside would have to be adjustable in some way. It'd be really, really difficult to insulate with rigid insulation. So that insulation for the slab edge can wrap to the interior of those dock leveler wells. Ideally, the dock structure would be built so that that leveler could be outside the thermal envelope, but that's not always feasible.
Loading docks are tricky.
Question about the receptacles. If at least 50% of receptacles need to be controlled, if you're using split receptacles, wouldn't that mean all of them need to have top receptacle controlled? Um,
I believe we've come down in our office as that is the strict interpretation, yes, from some conversations we had. I believe that, however, we're not exactly sure how that's going to be interpreted within the field.
in regards to that 50% of receptacles, though, if you have a 2-unit receptacle, uh, the individual receptacles, it has to be 50%. So not the
Yeah,
top and bottom counting as individual receptacles. So 50% of the units stuck in the wall have to have a controlled
right.
receptacle as part of that receptacle unit. So if you have a 2-unit or a 4-unit, um, depending on your setups for commercial spaces, 50% of those units have to have a controlled receptacle in them. Let's see. Question about the open plan offices. The 300 square foot is the definition separation between other types of offices and an open plan office. The maximum controlled area allowed for an occupancy sensor is 600 square foot. So it's not zoning between 300 and 600 square foot for those offices. It's an open plan office is defined as a space that's an office area with an open plan without dividing walls that's 300 square feet or larger, and then individual control zones within that can be a maximum of 600 square feet. Hopefully that makes sense. Question here about dimmers for residential lighting. Yes, there are a number of exceptions. So hallways, bathrooms, um,
I'm trying to remember too.
there's a couple of others. Um, but bedrooms, the kitchen, the dining room, the living room, those would have to have dimmer switches per the residential update to the 2021 IECC. That is correct.
Yes. That's a good
Uh,
question on the warehouses there. I don't know if you were going to get that one, but yeah, the warehouses that it would only apply to the conditioned area of the warehouse as long as the unconditioned area is truthfully unconditioned and meets the definitions of a unconditioned space. Um,
right, right. Yeah, so that pressure testing would apply to the thermal envelope of the conditioned area only of the warehouse. The unconditioned space would have to be broken by an air barrier and a thermal barrier and all that, completely isolated from the rest of the unconditioned warehouse.
mhm.
Uh, amend the dock leveler question. The wall will also have an uninsulated portion. You might want to follow up with an email to us with some
Yeah.
diagrams so we can better answer that dock leveler question. So please email us at energycode@illinois.edu. We'll get you a better answer for that dock leveler question. Trying to see if there's others we can answer kind of quickly in the chat here. Um, so lighting. The question about one of our updates for door thresholds that act as good thermal breaks. We'll have to come back to that one. Are the new requirements for process equipment for data rooms changing the intent of the energy code to control for comfort, cooling, or heating? So the new definitions added into the code were to specifically designate what is an equipment room, what is a data closet, what is a data center, as far as those different space types. For data centers, there are requirements now for equipment efficiency and sizing, which is why those definitions and stuff was added to the code. So there's a different procedure to size the equipment for a data center, and there are specific efficiency requirements for the equipment serving data centers. That was added into the code. Um, as far as um, controlling for other spaces like a equipment room, that qualifies as a separate space that doesn't have to meet the provisions of the envelope for the energy code. A data closet is within the larger building. There's no specific requirements in the code for a data closet at this time, but there are data closet units in the efficiency tables as far as types of mini splits, things like that, that I believe there are those efficiency requirements that have to be met for those types of units. But as far as control of those rooms, the energy code isn't going changing its take on applying to spaces for comfort conditioning and of for heating and cooling. It's more acknowledging data centers are a huge energy demand, and so there's specific sizing and efficiency requirements for those types of spaces. Um, Equipment buildings are exempt from the envelope requirements of the code, but the other control requirements still comply. You still have to have a thermostat. The lighting in there still has to meet the lighting power density requirements, things like that. Um, but as far as data closets themselves, they would have to comply again with lighting control requirements, lighting power density requirements. The HVAC unit in that space has to have a thermostat control that applies complies with the energy code requirements. But it's not a change in the code as far as um, control for spaces that are for comfort conditioning versus non-comfort conditioning.
So a question come into the chat here. Would a hot yoga room be comfort cooling? Well, a hot yoga room, the systems in that room will be considered conditioned system. That space is a fully conditioned space. Um, Whether it's comfortable or not is your own call, but that is a fully conditioned space and must meet requirements for a fully conditioned space. Um, and then I see a question in the Q&A, is pressure testing required if the space is semi-heated? Semi-heated is a definition that actually comes from ASHRAE 90.1 and not from the IECC. So in terms of is pressure testing required for that space? I am not sure off the top of my head, but you would need to go to ASHRAE 90.1 for that rather than the IECC. Um,
Yeah,
I don't
the
know, Sean, if you've got something
IECC
to add.
doesn't make a distinction between semi-heated and fully conditioned spaces. If you have a semi-heated space and you want to take advantage of that, you would be complying using ASHRAE 90.1. If you're complying using the IECC, that semi-conditioned space needs to meet the full insulation requirements as if it's a fully conditioned space. Control, heating, lighting, all that would apply to it as if it's a fully conditioned space.
Including pressure testing.
Yes.
Yeah. Now it could potentially qualify as a low energy space within the IECC, but that bar for a low energy space is really pretty low.
Yeah.
So the semi-heated is not the same thing. ASHRAE's 90.1 semi-heated is not the same as IECC's low energy. There's some differences there, I would say.
Right. Yep.
Um,
Question in the Q&A about inserting storefront glazing pavilion in between two wings of an existing building. Do we need to address performance above code? Can this be compensated by better roof insulation or an overall envelope? This is an interesting question. Um, so you've got a conditioned building that you're inserting the vertical glazing between those, since it's conditioned space on either side, doesn't have a specific energy requirement. If you're talking about inserting like a glazed skylight type storefront, maybe for that space, then that glazing would have to meet the U factor and solar heat gain requirements for the thermal envelope of a building. So maybe follow up with us with a more detailed email on that question and we can get you a better answer. But from my understanding, if it's vertical glazing between two conditioned existing building portions, there's no requirement for that because it's all within conditioned space. If it's skylight glazing that's being renovated into that space, then that glazing would have to meet the thermal envelope performance requirements.
I'm looking at the question from James Smith there. It's that's close to correct for existing buildings, but it's not necessarily just if the building is if the renovation or remodel is greater than 50%, it must meet the new code. Depending on which section of the existing buildings chapter of the code you're in, it is the if you are replacing this exterior wall, the new exterior wall that goes in place must completely comply with the code as if it were a new building, but you do not need to touch anything else in the building. So oftentimes the way that we describe existing buildings within the code is that if you're touching it in an existing building project, then it needs to meet the requirements as if it were a new building. If you're not touching that as part of the project, then most of the time the code does not make you update something that is not within the scope of the project. So hopefully that adds a little bit of clarity there. I don't know, Sean, if you have anything else to add.
Yeah, it gets a little bit tricky for remodel. If you're altering a portion of the building, there are certain alterations that do not have to fully comply with the code, such as one of the main examples is if you open a cavity in the building and there's insulation in there that fills the cavity already, you don't have to pack in more insulation. It's already in compliance for that, for an existing alteration. Um, there are others that have specific requirements. We'll get into those when we do our commercial existing buildings in May.
Mhm. And we do have some online modules that talk about that already and some other resources. So if you can't find what you're looking for, ask us a question and we can help you
Mhm.
out.
And then summarizing the requirement for manual overrides for controlled lighting and receptacles in open office areas. So anywhere that you have an occupancy sensor that can automatically turn the lights off on a time delay, you have to have an ability to manually override them off by the occupant in the space in case they want the lights off
Mhm.
before the sensor would trigger them off, or the sensor can't trigger them off because there's an occupant in that space. Similarly, for time clocks, there has to be an override that can allow them to either be turned on. If the time clock turns them off and someone's still there, they need to be able to override, turn them back on. And then after a couple hours, it resets back to that time clock schedule, um, or to turn the lights off early if you want to do so. So those overrides are just to provide occupant control if they need something different than what the automatic controls would provide.
Mhm.
Um,
However, I don't believe there is any language for overrides for controlled receptacles. Um,
yeah.
Not that I am aware of. I believe those controlled receptacles are controlled 24/7 all the time.
Mhm. And that's going to be something for designers and building owners as that rolls out. That's a communication update to the building occupants. They're going to have to be
Right.
aware certain receptacles are marked as controlled. Certain things you don't want to plug into that, like IT equipment that might need to stay on 24/7, or servers, things like that. Um, we've run into those issues in the past with buildings that tried to implement those controls early or under the ASHRAE standard, where people had complaints about equipment shutting off and then they couldn't remote in when they weren't there, things like that. So you have to be careful what gets plugged into those controlled outlets. It's generally peripheral and supplementary equipment, and then key equipment is plugged into the uncontrolled receptacles. So that would be something that just needs to be communicated to building occupants now. Question here about since mass walls require continuous insulation by the R value method, and now framed walls must have continuous insulation, can you take the U value method of the mass wall if all insulation is cavity-based insulation, which is much less stringent than U value of a wood metal framed wall? So no. Um, if you have a mass wall, it must meet the mass wall U factor requirements. If you have a metal framed wall, it has a specific U factor requirement for a metal framed wall. You can't blend those different assembly types because there is a thermal mass benefit to the mass wall that the metal frame walls don't have. So if you're putting framing inside of a mass wall and insulating it, it has a less stringent requirement because the mass wall itself has the ability to store heat, which can offset loads a bit, and has its own insulating value that a metal framed wall does not have. Um, I think that's most of the questions. We have one here about solar heat gain differing between fixed and operable lights um, when the glazing in them is typically the same. Um, while that is true, this is just providing an allowance, acknowledging that there is a performance difference between a fixed window. It's usually more airtight. And so there's less risk of drafts and stuff. So it has better control. So it has a slightly less solar heat gain coefficient and U factor requirement than an operable window, which is necessarily going to be a little bit more prone to leakage and drafts. So they're giving you that ability to trade off, um, anticipating that the entire window assembly is going to be operable or fixed, and not really trading off between like curtain wall assemblies where you might have a mixture of those. Um,
Uh,
yes, slides will be uploaded to our website and available to download after this presentation. Might take a day or two to get it uploaded to the website, but it will be available. So just check back regularly and you'll find it there. And that, I believe, is all the questions that have come in. So thank you all for attending. Thank you for staying late as we answered all your questions. Again, if you have specific questions, something we didn't get to in the presentation, you need more clarity, please reach out to us at energycode@illinois.edu or give us a call at that 1-800 number. Thank you all for attending today. Hope you have a wonderful afternoon.
Thank you.